All right, first topic we're going to look at here in chapter 12 is what we talk about as series and sequence. And we're going to look at a couple specific types, arithmetic and geometric. There are many types of series and sequence. And what we'll start out with talking about is what is a sequence. Well, a sequence is just a list, okay? And it doesn't necessarily just have to be numeric. It could be anything, like a grocery list when you go shopping. There's a sequence of products you need to buy. But we're going to deal mostly with numbers here. And sometimes those lists will have patterns that you'll be able to see right away and tell what's going on and how we could create the next value in that list. Sometimes it'll be that we're adding the same thing. Sometimes it'll be we're multiplying the same thing over and over and over again. Sometimes it might not be as obvious, but there is a pattern. Okay, one for you to think about and see if you can come up with it. Other times you won't see anything. It could just be some random numbers being put down in a list, and there's your sequence. So when we talk about arithmetic, what's going on is we're adding a value every time to the list. So that would be this first example up here. What I did to go from 1 to 3 was I added 2. Added 2 more to go from 3 to 5, so on and so forth. And what we're going to call this is a common difference. And we're going to call or use the variable d to represent that common difference. Okay, and so what we're kind of looking at doing here is I'm starting out with, excuse me, a, which is my first term. Now we're going to also talk about these more in terms of subscripts. Okay, so a sub 1 means I'm talking about my first term in the sequence. Okay, then what I'm going to do is get to my second term, so a sub 2, okay, which all I'm doing is adding that common difference. Okay. So for my third term, what I already have is a plus d, so I added another d on. The fourth term, I had a plus d, okay, and so then I added on yet another d. And so what we're looking at here, then I could simplify it down, is that I have a sub 1 is a plus d, a plus 2d, a plus 3d. Now, what we're going to look at here, and this will come up in a little bit, is the relationship between how many d's I have and my subscripts. And there is a nice little relationship here that most people notice right away, and that 0 to 1, 1 to 2, 2 to 3. My subscript, 1 less than that, is how many d's I've added on to that initial piece that I started with. Okay, so what we're going to look at here is now find the next 4 terms in the sequence. Yeah, pretty easy sometimes to see what we're adding or subtracting. Now I know it's adding or subtracting because of the fact they told me it's an arithmetic sequence. But number one, we got to find that common difference. We got to find d. Okay, and so there's a nice little process that we're doing. And if I think about what did I do to go from -5 to -2, well, I took -5 and I added some common difference to it to get to -2. Okay. Now, if I go in here and solve for d, I need to add 5 to both sides. But what I'm going to do is I'm going to do it this way. I'm going to subtract a -5 because I'm talking about a common difference. Difference we know is subtraction. So what I'm actually doing to get d is taking -2 and subtracting that -5. Okay. Now, I could do the same thing with the -2 and the 1, but what we look at, and there's a lot of ways you can notate it using that subscript idea, but what I tell people is just take any term and subtract that previous term. And if I did not tell you it's an arithmetic sequence, you would have to go determine if it was, and that's one of the ways we go about doing it. We found out that going from my first term to my second term, I added 3. Well, from my second term to my third term, take any term minus the previous term, also got a common difference of 3. And so now that I know that common difference is 3, I can find the next 4 terms by adding 3, adding 3, adding 3, adding 3. Okay. But now what if I want the 47th term? Okay, and when I look at this 47th term, I don't want to go list 47 terms out. Okay, and 1 is time consuming, 2, it's a lot more work than what we need. Now if you go back a couple pages here, we talked about the relationship between my subscript and the number of d's, and that it was 1 less. So basically, if you look at every one of these, what I have is my first term, and I'm adding on some number of D's, and that number of D's is always going to be 1 less than whatever that subscript was. Okay, and so that's where this formula is coming into play. Okay, this is my formula for an arithmetic sequence. Now, the piece that throws people off is the a sub n once in a while, so you got to be careful with that. Once you recognize what n is, write that n down, that value for n down with that subscript as well. So when I talk about find your 47th term, well, n is 47. Okay, n is how many terms are in this sequence. Okay, I'm cutting the sequence off at 47. Here's my first term. Okay, so what I want to find is what's the 47th term. Okay, so I want to find a sub 47. I know my first term. I know there's 47 terms. Well, and again, I got to go find that common difference. Like I said, I can take any term and subtract the previous one. And again, we find out it's 3. Now, one of the things that some people may want to do is look at these two terms, because then I don't have to deal with the negatives. And subtracting a negative, even though we shouldn't, we do make that error from time to time. And now you're just into some simple algebra where you're simplifying an expression. So your parentheses, okay, and then your multiplication, 120 and 18, and then your addition. Okay. So the 47th term in that sequence, if I kept adding 3 over and over and over again, would get me up to 134. All right, when we talk about writing an arithmetic sequence, that's 5 arithmetic means between 4.9 and 2.5. Okay, it means I'm going to start with 4.9, I'm going to end up with 2.5. Now, what an arithmetic mean is, it's simply talking about your average. So if I just wanted one arithmetic mean in here, what I would do is find the average of these two values. Okay, but they want 5 of them in there. Okay, so they want 1, 2, 3, 4, 5. Okay, and so they're finding all these values that have this equal distance between 4.9 and 2.5. Okay, so what we got to look at again is, what do I have? What do I need to find? Start plugging things in the formula. So this is a sub 1. That's my first term. A sub 2, 3, 4, 5, 6, a sub 7. And this becomes important because when I get to a sub 7, that's my last term, is sometimes how people look at it, but it's a number of terms in my sequence is 7, so n equals 7. So when I go to my formula, I'm going to start filling things in, because I should be able to get to a point where there's only one thing missing, and that's the one that I'm going to solve for. When I'm looking at a sub n in this case, I'm talking about a sub 7. I know my 7th term. Okay, I could even go here. I know my 4th term. Okay, but I know my 7th term, and the value of that term is 2.5. You got to understand, a sub whatever is always talking about one of the terms in my sequence. I know my first term. And like I said, I now know that there's 7 terms in my sequence. So the only one I don't know is D, and so I can go about solving that, and we'll be set. Okay, so again, it's just some algebra. We can solve an equation, so I'm going to subtract 4.9. And most people don't write 7 minus 1, they'll just go with the 6. Divide by 6, so we get negative 0.4 is my value for D, my common difference. Okay, so negative 0.4, I'm going to subtract it from a term to get to my next. Subtract it. Notice I subtract it, and I got to that 3.7 again, which I expected. Subtract it, and always subtract to make sure you get to this one back here, the end, your 7th term. Because if you don't, then that means your difference might be incorrect. All right, next piece. We talked about how we're going to look at series and sequence. Series is related to a sequence, and what I'm going to do is I'm going to, excuse me, add up all the terms in my sequence. Okay, so if I had this sequence here, 1, 2, 3, 4, all the way up to 10, if I wanted to find the series, now what I'm going to do is add each of those pieces together. Okay. Now, short series, pretty easy to go 1 plus 2 plus 3 in your calculator. Okay. And what you'd end up seeing is that it's going to be 55. Okay. Now, what if I wanted 100 terms added up? I don't want to do that in my calculator. So here's my series formula. Okay. Capital S sub n talks about the sum of n terms of a sequence. Okay. And again, obviously, your number of terms, a sub 1, your first term. And here's the one where I talked about a lot of times people refer to that as your last term, a sub n. Okay. But what it is, once I figure out my number of terms, in this case, 10, this now becomes a sub 10. This now becomes s sub 10. Okay. Now, what I'm going to do is I'm going to plug the numbers into the formula and show you how it comes about here. Okay. So what I have here is 5, because I've already plugged in my 10, my first term, plus my last term, my 10th term. And there's your 55. Okay. Now, where it comes from. So if I took that first and last term, add them together, I get 11. Well, look what happens when I take the second and second to last term, third to last term. Okay. Anytime you do that with a sequence, an arithmetic sequence, those two pieces on the outside will always add up to the same value as I work my way in. Now, this part, the 10 over 2, if you notice there are 5 groups of 11, but where that comes from is the idea that when I break things into pairs, how many ever I start with, if I divide that by 2, that's going to tell me how many pairs I have, and that's what I'm doing here. I'm putting pairs. I'm putting one on the front, one on the back together. Okay, so that's where that formula comes from. Okay, so to find the sum of the first 60 terms, okay, so I'm looking for s sub 60, 60 over 2, my first term is 9, my last term is 304. That quick, that easy to plug things in. And think about it again, 60 pairs, or 60 terms, when I break them into pairs, going to give me 30. And if I even went backwards, you can see your common difference here is 5, 299, and 14. That's going to give me 313, as does this one. Okay. All right, one last quick example here. And what's going on here in this one is that if I start filling in, find the sum of the first 35 terms, okay, I know my first, I don't know a sub 35. Okay, there's a couple ways you can go about doing this. One, I think it's easiest because we're dealing with a series, which is adding up all the parts of a sequence, all the terms in a sequence. Let's use the sequence formula to find the 35th term, because we know the first 35 terms. Okay, my common difference, 9 minus 7 is 2. Okay, I can calculate that. So 7 plus 34 times 2, 68 plus 7. So now I have this term to be 75. Okay, and yes, you can have a, half up here. What happens is there's one left in the middle, and it'll actually be half of that. So 17 and a half times 82, okay, whatever that comes out to be. Now, the book is also going to show this formula down here. Okay. It's just another one you have to know. Okay. And so if I can stick to arithmetic being just 2 formulas, I'm going to do that. Okay. Where it comes from, if you notice, all they did was they took and they substituted in the sequence formula, and then these two came together. If we plug the same numbers in here, 17 over 2, 2 times a sub 1 plus n minus 1 times your common difference. What you're going to find out is that you're still going to get the same 17 and a half times 82. All right, good luck with that. You're going to be looking at that as your assignment, the worksheet the second day.